Hello everyone. Today meeting is about BlueStore plans in Umbrella. I will not be sharing my screen because I do not have any valuable presentation. All that is important to see is in a short 8-point list in BlueStore section of the CDS Umbrella doc. Basically, I envisioned this meeting as a mix of me reporting what has been decided by the BlueStore extended BlueStore team on mostly that is having its meeting on each Tuesday. That's BlueStore upkeep and evolution meeting, and with a close cooperation with Igor Fedotov, who is the BlueStore lead. Mm, there is a list of things we want to get into Umbrella. Most of the things already do have some initial PRs, but in BlueStore it usually takes us a considerably long time from initial PR to actually merged condition. Usually because we are super sensitive to any bugs that may appear. Okay, so that's the first part. First part would be just a report what we want to do in Umbrella, and then I will turn on receive mode and listen to what maybe is necessary but we do not know about it, or what anyone else wants to contribute to BlueStore. But in that way, contribute means contribute. Okay, let's start. First on the list is improvement in RocksDB caching. There is already a PR we have. That's basically a bug fix. It's not even an improvement. We had since forever a very bad case of cache mismanagement that finally we noticed in a hello hi fellow Jigster, did you wanted to say something? Okay, I will assume no. We had a very severe problem in one of the customers that caused us a severe degradation in OMAP performance. Basically, it boiled down to the fact that because of intersection of splitting cache into shards and having sometimes RocksDB insert a very large cache elements, usually cache elements were about 4 kilobytes. Sometimes cache elements could be 1, 2, or even 8 megabytes in size. So that could cause some shards to completely be filled with just one element. And that caused a continuous eviction. That PR we will backport as far as we can, because I rate it as a bug fix. Next one. I really wanted Radek Zarzyński to show up for the next topic. It's an FIE map, that's an object store call, and flavors of zero support. That's basically an research. We do not have a PR for it yet. Research whether we can meaningfully signal object store. Basically, only BlueStore is doing that there is a distinction between zeros in objects that are not mapped, because when we read something that is not mapped, we put it as zeros, from zeros that have been actually written by a client. That distinction plays a significant role in some conditions, like RBD really would like to be able to distinguish that, because in effect it allows it to encrypt or do not encrypt some regions of the disk. So that's why it's important for RBD. Technically, for the easy solution, we could implement in BlueStore quite quickly. The true problem is that with erasure coding also needs to distinguish zeros, but hence there's a other flavor of problem with erasure coding, that erasure coded data we then cannot recover when we create a parity of meaningful zeros. That just doesn't fly. So erasure coding would need to preserve its own extra data to know which parts of object are truly mapped and which are zeros. Due to that, we still not started an implementation, because that would be like wasteful to have some significant change that affects only half of the cases, half the data storage methods. The third one, we have some ports for PowerPC of Ceph on the machines that have a typical 64K page size. That has turned out to be a problem, especially because we assume that 4K, we coded the software with assumption that 4K is the page size, and it did seep into how we handle intersection between direct writes to the disk and buffered writes. There is only one component in BlueStore that does both of the type of writes. It's BlueFS. It can, in some condition, operate in a direct mode, and you can also configure it into buffered mode when Linux cache it just is Linux page cache is buffering the data. The default currently is buffered mode, mostly because the bug we had with RocksDB cache implementation, I think. So that may change in future, but so far we have two possible modes. And the core BlueStore part, the one that writes block data, the main part of object data, it operates only on direct mode. And sometimes on PowerPC machines, there were cases when we wrote some data, but also the same page was written in the other method. And it basically caused, finally, when the page was written down, delayed to the disk, it was corrupted. So we need to make some revamp. I don't know how it will, how to even start it. But we need some work on how to handle systems with different page size. Most likely, if we finally get the RocksDB cache fixed, the solution will be just to use always direct IO, and hence the problem will go away. Specifically, there might be some other places in Ceph that do assume 4K page size, but maybe we'll know that later. So that's the positive scenario. Most likely, that solution will require us also to invest into creation of BlueFS cache. So like we have a caching for metadata, for decoded O nodes for block data, maybe also we would need to create an extra cache that is solely for BlueFS files. To move it from page cache just to management in memory, which I would very like, because that will allow us to better distribute the available memory between the caches. So I don't think we will do that finish that for Umbrella, but it's very likely that some of the things I just mentioned will be implemented in Umbrella. And now the fast round. We have already some work that is done and just needs to get merged. First one is fast O-node recovery. That's a work that stemmed from the observation that back. We have a mode in BlueStore to keep allocations not as a constant update in RocksDB, but as a separate in-memory state. We keep all the free allocations, allocator state. We need to store that state when OSD is shut down. It's going to shut down. However, if we crash, obviously we do not have that state. We created a procedure to recover the allocator state by reading RocksDB data, and everything is perfectly fine. But we tested that when drives were about 1 terabyte in size, and it took 5 minutes and it was fine. Now some drives are like 15, 30 and even more terabytes, and the procedure takes like an hour. That completely unacceptable, mostly because if OSD gets back so long, it usually gets marked as a down out and rebalancing starts, and all the problems just start to appear. The new procedure is just doing that work multi-threaded way. So that's just it. And it significantly reduces recovery time, as could be seen in a table attached to the PR. Next one. A mysterious person for me, a Gary Drankovich. I would like to see him on Cephalocon. Maybe he will appear. Made a PR that is making something that we wanted to have for a long time. Basically, to reuse the fact that we are reading objects on Scrub and use that opportunity to write objects back. It means that if an object data is fragmented, or it was compressed but not all of it, but compression is enabled, it could in one go recompress entire object. That gives us huge opportunities to make to continually keep objects in a best possible shape to just have the minimal latency. Recently on BlueStore meeting with Igor Fedotov, we realized that there is even more that we could do during that procedure. We could hijack the core of that optimization infrastructure to even optimize objects metadata. So we can do even more. So now the thing will be to negotiate how to make the optimization procedure that was proposed by Gary Drankovic most elastic, so we could make it as an open infrastructure to do also different actions at that time. I think I will get back to that recompression and defragmentation because there was something more I wanted to say, but now I forgot. Next is better alloc map persistency. That's related to the fast O-node recovery. The initial implementation of how we store allocations on disk has proven very inefficient. We did not realize it's so bad until we actually fragmented, not we, the customers got their data very fragmented, and the allocation context stored got very, very big, and it took really long to recover it. So that PR from Igor Fedotov makes it so we are better prepared for a fragmented state of allocator, and recovery is fast. Next one, a very nice tool that's basically not a BlueStore thing, but it was created by BlueStore contributor Jaya Prakash Madaka. The tool is used because it has already been used. The tool is used to measure optimizations that we do in a selected small function. The intention for the tool was that if we have planned or idea for a code improvement, something that we think that will just execute faster, but we're not 100% sure because we're doing some trading some qualities. That tool allows us to measure instructions, clock cycles, cache misses, branch miss predictions, and so on. And based on that, judge if some small change is getting us benefit. The value in that is that sometimes we have multiple ideas for small improvements that we are not able to convince ourselves that they really get the benefit. And when doing a large scale testing like IO writes, performance or latencies or so on, the variance of the testing otherwise is so much that we basically don't know. With CPU trace, we are able to be confident that the change we make gives us 1% improvement. And that is something that we are willing to go for, iteratively accumulate 1% improvements and get the code faster. And with that tool, we opened a series, the entire project of modifying how we process and store metadata in BlueStore. The change here called white overhaul is completely transparent, meaning there is no change in any external externally visible artifacts. The data is the same, just in memory state is different, and we're decoding it different, and so on. We don't know which of the concepts mentioned in point 8, BlueStore processing improvements, will finally got merged. It just depends on whether the CPU trace, and on larger scale just regular testing, will show. We intend to make better use of cache locality using PMR allocators that Bloomberg has been advocating a lot and has a lot experience with, meaning that with processing objects, we will keep all the memory allocations that we previously had dispersed throughout memory in a concise form. For example, if objects gets evicted from cache, we will basically forgot entire mini allocator that we used for all the data. That's one line of improvement. The second line is we intend to squeeze the memory wastage for keeping BlueStore BlueStore data and BlueStore ONNODE metadata just smaller, so we can have more space for caching. But again, that I don't think any of it will get merged for Umbrella. It's just the process that we'll be doing here. And that's it. That's what basically is planned for Umbrella. I would be very happy if you guys could suggest what should be maybe some path of improvement that we have not seen, and propose something either here, or please visit for Tuesday BlueStore upkeep and evolution meeting.